Hello Quest kids, I hope you're studying well for your test. I'll first just show you an image that gives you the key to the first part on the types of waves in the electromagnetic spectrum. You can see on this part I've got all of the different uses and dangers of the different types of rays, and then as well I've got them sorted in order of size, gamma ray being smallest, radio wave being largest. Go ahead and pause on this part of the video if you need help checking what you have written down. What do we know about links between radio waves and cancer? And we're talking about big radio waves, not gamma and X rays. But what we do know based on research is that it's really unclear. There might be a link, there might not be a link. We need to do a lot more studies on it. What we do know for certain is that long-term exposure to things like radar equipment or to microwaves, things like that, that we do see an increased risk for cancer. And we also know that if the equipment is faulty, like if your microwave leaks or if your radar equipment has major issues, that we do see increases in all kinds of burns and accidents, and then as well in some cancer risk. How is light produced? There are many ways. Chemical reactions, either just in a beaker with regular chemicals or in biological organisms or caused by heat, but in every case it is caused by excited electrons that are kicked up into a high energy state and then they fall from that high energy state, and when that happens it produces light. What makes light have a higher energy? If the wave of that light has a higher frequency. So if we're talking visible light, Roy G. Biv, if you guys remember that, red light has a very low frequency, a very low energy, and then violet light has a very high frequency and therefore a very high energy. The units that we use for measuring light are lumens, not Lubin like the principal, but lumens, and you won't really need to know much of that for the test. As far as the colors, you can see the chart at the bottom. Hopefully that's a good enough key for you. But if an object appears white, what colors are being reflected? All colors. White light is a combination of all colors of light bouncing back to your eye at the same time. If an object is appearing black, that means none of the color is being reflected. All of it is being absorbed. If you see an object as green, that means everything is being absorbed except green. Green bounces back, hits your eyeball, and that's why you see it as green. When light strikes an object, there are three things that can happen to it. It can be reflected, it can be absorbed, or it can be transmitted. If it's transmitted, we're going to say that three things can happen to it. It can either go through completely a transparent substance. That would be something that's completely clear, like perfect glass or clear plastic or really pure clear water. If it's a translucent substance, that means only part of the light goes through, or that light gets bounced around, gets confused a little bit. So that's what happens when light passes through stained glass, or like a frosted lampshade, or a really thin curtain, or even water that has a lot of ripples in it, or a lot of murky, muddy stuff in it. If it's an opaque substance, the light won't pass through at all. That would be something solid like a steel door, or a wooden wall, or a chunk of rock. Alright, so when light is reflected, it can either go off of an even surface or an uneven surface. If it's bouncing off an even surface, all of those rays of light are going to come off at the same speed and at the same angle. That gives us a very clear image. If it's hitting an uneven surface, they're going to bounce off at different angles. It's all going to get very unclear, they're going to get distorted, and that's what you would see in like a funhouse mirror, where the image is not quite the same as what it started out to be. What is the difference between concave and convex mirrors? A concave mirror, remember, it caves in. So an example of that would be the inside of a spoon. So when you look at that image, it's going to be upside down and much smaller because of that curving in the mirror. A convex mirror is going to go out. It's going to bulge. You'll see this type of mirror on like a vehicle. So if you've got a big truck, sometimes the side mirrors will have an extra little rounded mirror on them. You also see these in stores. They're used for security purposes because that helps make an image larger. The laws of reflection, you won't have to know all five in order. You don't have to memorize anything there. There are just a couple things I want you to remember. First of all, if it is a plain or flat mirror, you should see the image is reflected with the exact same size and shape. If it's a funhouse mirror, of course, it's going to be distorted, but that is a general rule, same size and shape. All the images are virtual, and they are always going to be left-handed. Then the most important part of it is that the angle of reflection always equals the angle of incidence. On the diagram there, it's a little small to see here, but I'll zoom in just a second. I'm going to be labeling the incidence ray, the angle of incidence, the reflection ray, the angle of reflection, and the normal line. Alright, so that was our angle of reflection. This wedge right here is the angle of incidence between the incidence line and the normal line. And then those together, the angle of reflection and the angle of incidence, should always when light bends because of a change in speed. Can light refract if it strikes the surface at a 90-degree angle? The answer to that is no. It has to strike, so this would be a 90-degree angle. It's all going to reflect back and then go straight through. It's not going to bend. However, if you put it at an angle, then maybe it might do one of these before it moves on, okay? If the speed of a ray of light decreases as it passes through a substance, that ray of light is going to bend toward the normal line. If it's going to increase as it passes through a substance, it bends away from the normal line as it increases in speed. Next, I've got a diagram. You're going to label all of those different parts. I'm going to zoom in for you here and you can see. But remember, the incidence line is the one that comes from the flashlight toward the object or toward that surface. Then we have our refracted ray, which is what's kind of getting bent as it passes through the object. The angle between the normal line and that first starting ray of light is the incidence angle. The angle that forms between the normal line and the refracted ray is going to be the angle of refraction. And remember that the normal line is always at 90 degrees from the surface of our substance, of our boundary. In this case, it's a glass block, just like we did in our lab. Snell's law is all about calculating either the angle of incidence, the angle of refraction, or the index of refraction, so that relative speed that light travels through a substance. So the equation is Ni times sine theta I equals Nr times sine theta R. What does all that mean? Well, N is that index of refraction. Theta simply is a Greek letter that means angle, and then that sine, S-I-N, is a geometry term. All you need to know is that it's a button on your calculator, and it's something that we use to calculate this. When I set up the problem, I'm going to write out the entire law, and I'm going to try and simplify to solve for my missing piece. So in this case, I'm trying to solve for the index of refraction, Nr. So I'm going to divide both sides by sine theta r. So my new equation is Ni times sine theta I divided by sine theta r equals Nr. Let me zoom in on that work a little bit for you. So here you can see it a little bit better. I've got the problem set up. Now all I have to do is enter in the numbers that I've been given. I know that Ni is 1.25, and then I know sine theta I is the same as sine 55. Sine theta r is simply sine 85. So I've got it set up. Now let's use our calculator to figure out the numbers. 1.25 times, and if you enter it in your calculator, sine 55 equals 0.819. So I'm going to leave it like that for now. On the bottom, sine 85, when you enter that in your calculator, gives you 0.996. If you're not getting those numbers, make sure that your calculator is set to degrees instead of radians. It's a whole confusing area of geometry. Alright, so now that I've got my numbers, I simply multiply and divide, and I come up with my final answer, 1.03. That means that the index of refraction for the object that my light beam is passing through as it begins to bend is 1.03. So this substance is almost as pure as air for our light to be passing through. It means it's speeding up as it goes through.